Okay, welcome back. Review 4. This is a cumulative review for lessons 15 to 21. I'm assuming that you've been through the guided notes and you are ready to kind of consider this like a rehearsal and as though we're doing a test together, a practice test, and then you can do the self-assessment on iTunes on your own. Okay, let's dive right in. Number 1, perform the indicated operation. We see its multiplication. We see we're operating on mixed numbers. So like I said, I'm going to walk in faith that you've been through the notes, and I'm going to cruise through this with ease. So we change this to an improper fraction, we change this to an improper fraction, and proceed. So 9 times 2 is 18, 19, 20. So we're going to have 20 over 9. It's negative. We're going to multiply that with 5 times 1 is 5 plus 2, 7 over 5. That's also negative. Now we know a negative times a negative is a positive, so I'm going to circle that. Negative times a negative is a positive. So we know the final answer, whatever it is, it's definitely positive, so let's write plus. We know that when you're multiplying fractions, you can travel straight across. Let me make that a little more clear that it's a 9. So let me grab another color here as I get ready to do some cross cancellation, meaning this. 5 goes into itself once, 5 goes into 24 times. And I wanted to notice, we have the answer key over here. We want to obtain that answer, but we're going to see how we do that. So again, negative times a negative, we know is a positive. When you multiply, you just go straight across. So 4 times 7, that's going to lead us to 28. And 9 times 1, that's going to lead us to 9. Now you might be looking at this saying, hey, how is 28 over 9, 3 and 1/9? Well, it is. I mean, think about it. If you have to, go off on the side. 9 goes into 28 3 times with how many remaining? 1. 3 and 1/9. 3 and 1/9. So now we see that. Okay, let's head to number 2. Simplify the fraction. That means reduce the fraction. When in doubt, expand it out. So we recall from the guided notes that we're going to take a look at how 58 breaks apart into a product of factors. Well, we know 2 times 29. And 29 is prime, so that doesn't break any further. And then times x. So when in doubt, expand it out. I'm going to write 58x like this. Now you might have to go off on the side with 86 in terms of breaking it into its prime factorization. So you might be looking at it like, okay, 2 times 43. 43 is prime. We cannot find a number that goes into that other than 1 in itself, so I'll just circle both of those. So now I'm going to record here, when in doubt, expand it out. So 2 times 43 times x. And then we know that we can cancel common factors. So I'm going to grab blue here, cancel the 2, cancel the 2, cancel the x, meaning they divide out, right? And what are you left with? Voila. You're left with 29 over 43. So again, I left the answers kind of hovering there to the side so we could see how to obtain them. Let's go to the next one. This is order of ops. So we would like to do, I'm going to write PEMDAS, we would like to do what's inside the parentheses first. So 2/7 times 2/3, I know I can just travel straight across and call that 4 over 21. And I'm going to keep the divided by symbol. But we know that division means multiply by the reciprocal. So let's go ahead and do that. So we know that this is the fraction that gets flipped, as we see. Now we could travel straight across and get big number on top of big number, or like I said, we could look for cross cancellation. I'm going to go in faith that you're getting comfortable with cross cancellation. 3 goes into 15 5 times. 3 goes into 21 7 times. 2 goes into 4 twice. Look for common factors. And 2 goes into 14 7 times. And then if I travel straight across, 7.7, or 7 times 7 is 49, but it's negative. Negative times a positive is negative. So I've got negative 49 over, and then downstairs 5.2, or 5 times 2, is 10. And voila, we got the answer. Okay, let's try the next one. Division again, so I'm going to rewrite it. 8y over 21 divided by means times by reciprocal. And then I'm going to, because 3 cannot go into 8, and 8 has no common factors with 21, I'm not going to cross cancel. I'm just going to travel straight across. So 8y times 8 is 64y. 21 times 3 is 63. And voila, we got it. So I just want you to see in real time how you perform these. Again, remember, when you're multiplying, you just travel straight across on the numerators and the denominators and multiply. Okay, with this one, we have the freedom to convert all of these mixed numbers to improper, or we could try to get an LCD with just the little side fractions. So I think that's what I'll do. You have a little bit of freedom there how you want to do it, but 2, 4, 6, aha, they all go into 12. So let's rewrite all those little side fractions as something over 12. Well, 1/2 is clearly 6 out of 12. 1/4 is 3 out of 12. And now this one, how does 6 become 12? Times by 2. So we have to times the top by 2, so that'll become 10. So rewriting all those little side fractions with the common denominator, now I'm going to add all those, 6 12s and 3 12s and 10 12s. That's going to bring us to what? 16, 17, 19 12s. 19 12s. Now I'm going to go ahead and add the whole numbers. 3 plus 2 is 5, plus 5 is 10. If I arrive here, it's awkward, right? Because 19 12ths is an improper fraction. I can't leave it like that. Note to self, I need to carry. So how do you do that? Well, 12 goes into 19 once, with 7 remaining. I'm going to carry the 1, meaning add the 1, woo, add the 1 onto the 10 to make it 11, and then your leftovers, 7 12ths. 7 12ths. And voila, we got the answer. So again, in the 19 12ths, you have to remember how to carry. So you convert it to a mixed number, which it would be 1 and 7 12ths. But you take that 1 and basically carry it onto the 10, add it onto the 10, making 11. And then you've got your 7 12ths left over. All right, so big thing is do you remember how to carry? All right. Simplify the complex fraction. One way we dealt with that was, in the notes, was to multiply the entire fraction, and I'm going to rewrite it larger here. So 3/8 plus 4/7. And when we hear downstairs, we've got 1/4 plus 1/7. One way we dealt with that in the notes was to draw giant brackets around the whole thing, pick an LCD for all the denominators, which would be 56, and send that through to all the numerators in the problem. And that poof, via multiplication, and then poof, the whole thing's going to clean up. Now, one way to do that, let me just talk it through here. So 56 times 3 is some big number, right? And then you would take that big number and divide it by 8. But the thing is, you can reverse the flow. You can take 8 into 56, which is 7, and then times 3, which is 21. So I'm hoping you're going to catch what I'm doing there. I'll say that again. 56 times 4 is some big number, and then I could divide it by 7. But I can reverse the flow and divide first. So 7 into 56 goes 8 times 4 is 32. And this is just a shortcut gizmo for dealing with this. Here, 56 times 1, well, that's 56. And 56 divided by 4, you might have to go off on the side and think about that. It's 14. That's going to bring us to 14 there. And here, 56 times 1 is 56, divided by 7 is 8. Now, if I arrive here, that's great. I just have to keep cleaning. So that's going to bring me to 53 in the numerator, and 14 plus 8, 22 in the denominator. And voila, we got the answer. Now, I do want to mention that this is kind of a little shortcut trick. The only other way to deal with it is to deal with it separately. Meaning, and I'll just kind of say that, you could take 3/8 plus 4/7 and get something, and then, deal with the numerator and the denominator separately. And that might be better for you when you're first learning. Add these two fractions and get something. Add these two fractions and get something, and then clean it up from there, is what I'm getting at. So if you do that, 8 and 7, the LCD would be 56, right? So I'd basically end up getting 21 over 56 plus 32 over 56, which would lead me to 53 over 56. And then in the denominator, just kind of thinking that through with you, in the denominator, 1/4 and 1/7, well, let me just kind of block that off. The LCD would be 28. So I'd have 7/28 plus 4/28, which is 11/28. And then if I was going to take it from there, and so I think that's a longer, harder path. I'd have 53/56 divided by 11/28, because this big fraction bar here really means divided by. So divided by 11/28, which really means multiplied by the reciprocal. And then you're going to see some, cancellation, cross cancellation. 28 goes into 56 twice, and guess what? After all that sweat equity, you're still going to arrive at the same answer. So long story short, I think if you can sell yourself on how to find the LCD for all 4 denominators and send that through to arrive here, that's a shorter way. Okay, ate up a lot of time on the clock with that one, so let's keep moving on. Some of these are quickies though. So write this mixed number as an improper. Well, 2 times 1, when you have 1.5, okay, 2 times 1 is 2 plus 1. So some people kind of make a map to self that this way you multiply and then you add. And you're going to get 2 times 1 is 2 plus 1 is 3 all over the original denominator, which is 2. So 3/2. Okay. This one is a fairly quick one as well. Determine whether they're equivalent. The answer says they're equivalent, but how? A really neat way to do it is called the means extremes property. If 2 fractions are equivalent, then the product of their means should equal the product of their extremes. So check cross products is the easiest way I can say that. Check. Is it true that 6 times 22 equals 12 times 11? Cross products. So that's going to lead us to what? 132, and this is also going to lead us to 132. Yep. So yes, they are equal. So long story short, you can check the cross products. Check cross products if you're trying to make little recipes for yourself. Okay, let's try the next one. Prime factorization of this number. By now I'm assuming we're pretty comfortable, so we know, for example, that 2 times 44, 2 is prime. 2 times 44 makes 88. 44 is going to break into 4 times 11. 11's prime. 4 breaks down into 2 times 2. So 2 times 2 times 2 times 11, which means this. Okay, let's try the next one. It says find the exact difference and the estimated difference. Well, I want to talk about the estimated difference. 6 1/5 is awfully close to 6. It's like 6 and some change, right? And 5 7/25 is awfully close to 5. So 6 minus 5 is 1. So that's going to be your estimated difference of 1. That's just an estimate, like a ballpark, right? Then if you actually wanted to perform the math, you have the freedom to change these to improper fractions, which I'm not going to do, or you can do the borrowing method, which I am going to do. So 6 1/5 minus 5 7/25. Obviously, the 25 is the LCD. So I'm going to convert this into 5/20, just this little side fraction here into 5/25. And this little side fraction here stays 7/25. It has the LCD. And then I'm going to think about subtracting, but 5 minus 7, 7's bigger than 5, I got to borrow. Big note to self, I'll do this in another color. Borrow 1 whole unit from this guy. So he becomes a 5. Slide the 1 that you borrowed, slide the 1 that you borrowed right there, and then take this and convert it to an improper fraction. So 25 times 1 is 25, plus 5 is 30, so you'd have 30/25. Now you can go ahead and subtract. So 30/25 minus this here 7/25 is going to lead you to 23/25. And subtract don't forget your whole numbers over here, but 5 minus 5 is nothing. So you're just left with this 23/25, and voila, that was the answer. Which makes sense because 23/25 is awfully close to 1. We haven't talked about converting that to a decimal yet, but it's awfully close to 1. Okay. Oops, make sure we got ready for the next slide. Okay, with this one, we want to solve the equation that contains fractions. The method we use is that I like to use is to take the LCD of 33, 11 and 33, take the LCD and send it through to all the numerators in the problem, and poof, those fractions are going to disappear. Okay, so 33 times 4 is 132. So we'll have 132x plus, and this is just a technique to clear the fractions. 33 times 10 is 330. Divided by 11 is this going to take you back to 30. So I know I'm doing a lot of mental math there. 33 times 3 is 99. And there's a minus sign, so I'm keeping that, 99x. And then equals. And then 33 times 13 is some big number, and then you divide it out by 33. So an easier way to say it is 33 and 33 cancel, and you're just going to be left with 13. Now, I can combine like terms. So 132 minus 99. Okay, so 132 minus 99 is 33x. And then I'm just going to keep recording. So plus 30 equals 13. And then we want to, subtract that 30 to the other side. So we have a 33x equals negative 17. Divide both sides by 33, and voila. we got the right answer. So again, I've snipped in the answer just so we can check it off. Now, the part that students mix up is this sort of recipe that you're doing here. 4 really means 4 over 1, and 3 really means 3 over 1. So what I'm really doing is saying 33 times 4 is a 132, and divided by 1, it doesn't affect it. So I'm arriving here at 132x. And here, 33 times 10 is 330, but 330 on top of 11 really means, 330 divided by 11, and I just did the mental math, it's going to be 30. Okay, so that's how we're arriving at 30 then. And that's how and so on and so forth. And 33 times 3 is 99. We got that. Divided by 1, it doesn't affect it. 33 times 13 is a big number, and then you divide it by 33, but you can see that the 33s would just cancel, and you're left with just the 13. Okay, so again, that's just a technique for dealing with fractions. There are other ways to solve that, and you can try those on your own. Okay, we'll head to the next one, multiply. Now, we had said that when you multiply, it's perfectly legal to travel straight across. Let's do it that way, just for grins and giggles. You could also look for cross cancellation. So 13 times 4 then would bring us to, what, 52y? And I'm just going to keep the negative out front because a negative times a positive is negative. 20 times 5 is 100. Y, that follows along. And then right there you can look for some cancellation. So the y's cancel. And 52 over 100, you want to think about reducing that. Now you might at first just say, oh, I'm going to divide by 2. That would bring you to 26 over 50 if you just divide by 2, but then you've got to take that down even. Try it again. Divide that by 2. It's going to get you down to, so I'll just write that. Divide by 2, divide by 2. That'll take you down to 13 over 25, which is the answer. Okay? The big thing is when you're multiplying, you travel straight across and then reduce. Okay, 13, we're adding, so we need the LCD. LCD is already existing as 4, so those are like. So we can just add like terms on the numerators. So negative 3 plus 1 is negative 2. So we have negative 2/4, which is the same thing as negative 1/2. That's why you see the answer as negative 1/2. So always reduce at the end if possible. Like negative 2/4 is right, it's just not reduced. Okay, we're going to try that same technique here on this equation with clearing the fractions. So I'm going to draw giant parentheses, pick a LCD of 10. This one will be easier to operate on. Send 10 through to the numerators only via multiplication. Numerators only via multiplication, and then divide out by the denominators. So ready? 10 times 3, 30, divided by 5, 6. Keep the negative. Try again. 10 times 3, 30, divided by 10, 3. Try again. 10 times 9, 90, divided by 10, 9. Okay, now what we've done is we've cleared the fractions, and that's legal, and it makes a nice equation to operate on. So we cleared the fractions, combine like terms, so 3 minus 9 is negative 6. And the last phase of the game to get x by itself is divide by negative 6. So we have x equals 1. And we got it. Okay, let's try the next one. Write this fraction in simplest form. We have the answer over here. You might be looking at it, here's a catch, you might be looking at it and say 90 and 117, they have nothing in common. But here's the trick. Think about numbers that go into 90. Okay, 9 and 10. Well, clearly 10 doesn't go into both of these numbers, but maybe 9 does. Just test it out. Okay, when in doubt, expand it out. So 90 really means 9 times 10. And I'm just going to hold that thought. and write 90 as 9 times 10, even though it's not its prime factorization, in the hopes that maybe 9 goes into 117 as well. Well, let's think about it. Aha, it does. So 9 goes into 27.3, in fact 13 times. So what I'm getting at is 117 can be expressed as 9 times 13. Now you can cancel the common factors, and voila. You're left with 10/13, negative, which is the answer. So the big psychology there is divide by 9, divide by 9. Whatever you do to the top, you got to do to the bottom. Find a common factor, perhaps 9. That goes into both. All right. Now we're going to travel straight across on this one. So that's going to be a squared, b squared, c squared, all multiplied with each other. So if you want, you could even put like a little dot in between. Downstairs, you've got c squared, a squared, b, but you can write it, it's commutative, right? So you can write it as a squared, b, c squared, just to have it neat and in order. Now we can look for some common factors to cancel. Well, a squared cancels with a squared, c squared cancels with c squared, and hey, you'd have b squared on top of b. If when in doubt, expand it out, that's b times b on top of b. Well, you're just going to be left with b. Okay. Hope that helps. Let's head to the next one. I believe we have 20 problems on this review set, so we're almost there. This one, there's only one fraction in the problem, so I'm not going to, multiply. I'm not going to try and clear the fractions on this one because it's small amount. -9 minus 3, -12y equals, there's only that one itty-bitty fraction, so I'll just deal with it if there's only one fraction. Divide by -12. Here I'm going to write divide by -12. I'm going to write it like that because division really means multiply by the reciprocal, right? Then we travel straight across and we arrive at 4 over -60. But guess what? 4 over 60 is equivalent to 1/15, right? And like I said, that negative, a lot of people are like, should I float the negative downstairs or side of it? It doesn't matter. You can float your negative to the side of the fraction if you like. Just knowing that it's negative. Okay, now we're going to try number 18. We're almost at the finish line, almost there. Okay, only have to make it to 20, and then you're ready to test yourself. This one, when we're adding, we need the LCD. So you might have to think about that. 72. So I always like to do the do-do rule. How does 9 become 7? 72 is the LCD. How does 9 become 72 times by 8? Whatever you do to the bottom, you got to do to the top. So 8 times 4, we're going to have 32x over 72. Plus, and how does 8 get to 72? You got to times by 9. Do to the bottom, do to the top. So again, 8 times 9 would make 72, but 9 times x would make 9x. Now you have the LCD, which is 72, so you keep the LCD, and you add the numerators. So 32x and 9x makes 41x, and voila, we got the answer. Okay, and now for the final slide. Add or subtract as indicated. When you look at 7, 5, and 14, it would be ideal if you could get the LCD for all 3 of those numbers. And I think 70 ought to cut it. So they all go into 70. So let's try to convert them into something over 70. So here's how I do it. 7 into 70 goes 10 times 3 makes 30. I just kind of do the mental math. Let's try again. 5 goes into 70 how many times? 14 times. And 14 times 4 is something. And sometimes I have to go off on the margin and think about it, if, especially if I'm not using a calculator. 56. So that'll be 56, and then 14 into 70 goes 5, and 5 times 13 is something. And like I said, you can always do that marginal work. 65. So that part will be 65. Now when you have that LCD of 70, you keep it, but check this out. You have a loss of 30, and then you got to add all the numerators. So, but be careful of the signs, because you've got negative means loss. So you have negative 30, gain 56. Well, that's going to bring you to 26. And then 26 minus 65. That's where you're getting that negative 39 from. Voila. Okay? And last but not least, simplify this complex fraction. I want to remind you that this division bar here means just that. So we can translate this to 5a over 42 divided by 1/14, which is then going to translate to 5a over 42 times by 14 over 1. You can do some cross cancellation if you like 7 goes into 14 twice, 7 goes into 42 6 times, and then 2 goes into itself once, and 2 goes into 6 3 times, and then travel straight across. So 5a times 1 is 5a, and downstairs 3 times 1 is 3. So I know fractions can be a rough spot for a lot of people, but I'm hoping you're getting more comfortable. All right? That is the end of that review. Hope it helped.